I'm Chen and coming from the Ohio State. And I'm here to present our work, FlexRadio. And this work is joined down with my colleagues, Vivek and Kannan. So we are looking at wireless devices which have multiple antennas and multiple up chains. We have a lot of these devices nowadays in our daily life. For example, the routers, the base station, and even the cell phones. Most of these technologies are pushed forward by the evolution of the MIMO technologies. So it can give us a fundamental capacity gains. We can enable more streams in the same spectrum. And with the MIMO technology here, in the last few years, with the introduction of full-duplex techniques, it can be seen as another technology also uses multiple RF chains to do the transmission. While MIMO would like to transmit or receive separately, full-duplex gives us an opportunity to transmit and receive at the same time. So a question will raise, how can we compare with these two technologies? And more fundamentally, we want to say that given a limited resource of RF chains, what is our deployment? How should our devices choose which technology should we choose? So to compare with a MIMO and full-duplex performance, let's first look at a very simple scenario of a pair transmission. Let's look at just the case of two nodes. Assume I have two nodes, and each of them has two RF chains. Active RF chains can be enabled at the same time. If it's a MIMO transmission, the left one will be the MIMO transmitter, and the right one will be the MIMO receiver. In this case, if we can enable two of the streams simultaneously based on the MIMO technologies, we can have a 2 times capacity gain over the one-to-one transmission. And for the case of the full-duplex, each radio has a capability to transmit one stream and receive another one. So in this case, we can enable 2 streams, one from the left to right, and another one from the right to the left side. So when we look at this example, we can see that both technologies are able to send the same number of parallel independent streams. Both of them are 2. And I mentioned here is I use the word RF chains instead of, if people are familiar, usually use antennas. Why I call it like this? I agree that antenna resource is important, but it is not the only parameter that determines how many parallel independent wireless streams you can have. For example, I recall that this is a story happens about 3 and 4 years ago about iPhone. At the time when iPhone 4 was released, there's a problem about the Wi-Fi for the call services. It's because when you hold the phone, sometimes you will get a really bad connection. So this is about iPhone 4. In the later version of the iPhone, start from iPhone 4S, they equipped the device with 2 antennas for the reception and transmission. But they only transmit 1 data streams, independent streams. How they use these antennas is in a manner that which antenna gives you a better channel condition will be used as a transmitter antenna. In this case, we can see that although we enable more antennas, it's still 1 stream that are transmitting here. So let's come back to the first comparison. We want to say that no matter how the radio is built, or no matter how the design is, the number of RF chains of a node determines how many independent streams the node can support. In this case, when we compare the performance of these 2, the MIMO and full-duplex, in this case, we'll find that they are same. They give you the same performance as the MIMO is 2, full-duplex also give you 2. And given MIMO technology is so mature, it has been evaluated in the last few years. What's the reason for us to introduce a full-duplex? Does it really give us a benefit? So before we see that why we have this FlexRadio, the solution we will get is that when the topology changes, when we go to a more complicated scenario, the story changes. It's not like the case in the pair transmission, that's true. These 2 are the same. These 2 give you the same performance gain. But when it goes to a more complicated cases, the story changes. And if we want to do that change, we want to see the real improvement of the network from the full-duplex transmission, the radio needs to do a cooperative manner. Means that radio needs to be able to assign its RF resources based on the environment, based on the channel, based on the neighborhood topology to see which is his best choice for the transmission. And this is the new dimension of a flexibility I want to explore. And we call it FlexRadio. Before I come back to say the story, how the FlexRadio will give you the benefit of capacity, let's first look at the structure about what is the radio we designed, what is a structure of the radio we have. Assume there's a 4-antenna 4F channel system, like shown here. Of course, we want to show that we can support different configurations. We support MIMO. It can transmit 4 independent streams and receive 4 independent streams. Also, it has to have the configuration of a full-duplex mode. Means that half of its channel are used for transmission and half of the channel are used for reception. In addition to these 3 configurations, we have 2 more. In the first case, 3 of them are used for transmission, 1 of them are used for reception. Other one, we have 1 for transmission, 3 for reception. This is our full-duplex structures, and our system is able to show the flexibility. We can enable nodes to any configuration of as shown here. So now let's come to the question I asked before. In which case, we can show the real capacity gain of the full-duplex capability. A node can transmit and receive at the same time. Let's first look at the case. Here's a case. We say that there's a flow demand here. I have 3 nodes here, and the left nodes have 4 RF channels, and the middle one has 6, and the right one has 4 RF channels. If we only have the MIMO capability for the transmission, what we will do? Since that the left link and the right link cannot be enabled simultaneously, what we can only do here, the only choice we have is do it in a TDMA manner. So in the first slot, we would like to enable the link in the left side. We ask 4 of the channels in the right side as a transmitter and 6 as a receiver. In this case, we can enable 4 independent streams. In the second slot, we try to see what happens in the right side of the link. 6 as a transmitter, 4 as a receiver, and totally together, we also enable 4 independent streams. So no matter how you separate the time for these 2 slots, MIMO will only support 4 independent streams in this case. What about full-duplex? If we have the full-duplex capability, as we called, every node will assign half of its RF channels for transmission and half of the channels for reception. In this case, this is what we can do the best for the full-duplex configuration. Left nodes have the 2 for the transmission, right nodes have the 2 as a reception, and the middle node will have the 3 for, in the case that the full-duplex node has 3 for transmission and 3 for reception. Left link, we have 2 streams, and the right link, there are 2 streams. Totally together, also 4 streams. It's the same. So what should be the choice? If we have the flexibility to assign the RF channels in each radio to see what is their configuration, here's what we can do. Left node treated as a MIMO transmission, and the right node treated as a MIMO receiving. And the middle nodes operating in a full-duplex manner. In this case, left one, we have 3 independent streams. Right one, we have 3 independent streams. Totally, we have 6. And this is a 50% increase compared to the MIMO or full-duplex alone. This is the case. We show that we have the assumption about the flow dimension, and maybe we will say this is because we have a different number of RF channels in different nodes. The next example I will show you is that I remove all these conditions. I have a very general case that every node has the same number of RF channels, and every node, I don't have any flow requirement for the nodes. I will show that FlexRadio also gives you the benefit. The topology is like this one. It's a diamond topology. We have 4 nodes here, and except the nodes, the link from the A to D, all the others can see each other. And if in the MIMO case, we want to transmit from A to D, assume we first try the transmission from A to D, and 2 streams are enabled. In this case, C cannot transmit. As if it transmits, it will interfere with reception in B. And C cannot receive because it already sees the interference from the node A. So C cannot do anything. And in this case, D itself cannot do the transmission and the reception. That's the maximum you can do with a MIMO configuration. What we can do is a full-duplex. Also, let's try this link from the link A and to link B. And for the same reason, you will find that node C is not able to transmit or reception at any time. And that's the maximum you can get. For all these two examples, I only show what happens if I enable one link. And you can try with all the others. You will find that this two number is upper bound. No matter how you schedule, no matter how you try your best, this is what you can get. Let me show you the magic. With FlexRadio, let me enable 3 streams in this topology. And these streams I enable like in this way. I enable one stream from A to C. I will show another stream from B to D. And I will show a third stream from A to B. Three of them together will fit into this topology. How should I do this? And all the radios to do this one, all the radios to cooperate and configured in the following way. Radio A will be treated as a transmitter. And the radio C and D, these two will be the receiver. And the radio B will be the full-duplex mode. In this case, I can see these 3 streams. First of all, let me try to inject this stream A into the red stream into the network. A will transmit to the signal. It's intended for B. But we can see that there's an interference at node B. But don't worry. We have 2 antennas to send this one stream. So what we can do? We can do the nulling here. We can do a pre-coding of the parameter of the signal from the node A, of the red stream, so that I can null the signal from B. As if the reception radios at node B will not see any of the interference. Second time, I inject the blue one into the network. Just ask the full-duplex transmitter to transmit the data. Since we have the self-interference at the node B, there's no interference at node B. And there will be 2 signals, one of them in D as an intended received signal, and another one will be arrive at C. Third time, I will inject the last radios, the last streams. That's a green one. The signal will transmit in this way, and it can be easily captured in node B. And the interesting part is look at the signal at the node C. We have 3 streams here. The red, blue, and green, all of them are here. But I only have 2 channels. I cannot decode these 3. What we can do? We still have not do the pre-coding for the green signals. We can do the pre-encoding and do the pre-coding through the green streams so that it can be aligned with the blue one. If I do this, these 2 streams will be aligned. So now at the node C, I can decode the red streams. I see another 2 streams are already aligned. They only occupy 1 space. In this case, we can see that node B and C and D, all of them together, each of them will decode 1 stream, and we decode 3 of them together in this topology. What we need here is a FlexRadio, and you have the flexibility to assign the nodes to different configurations. So this is how we can get, why we need the FlexRadio. Let's see how we build it. For the building of the FlexRadio, what is hard? Why it is not easy to have? We know that even we have spent so many years to try to see that how to build a real full-duplex node. Even one full-duplex node is hard to build. Not to say I want to have a radio that has all these configurations. I want to do all these configurations into one radio. The complexity grows really, really large. So I want to support MIMO. I want to support full-duplex. I want to support other configurations. All of them together, the complexity grows a lot. So the key design principle in which we try to build this system is that we try to utilize a module in one configuration and use it as many times as possible in all the configurations. This is design protocol. we put it, no matter in the RF part or in the digital part or nonlinear signal interference cancellation, we put it all the way in our design. And here, let me show you one of them, the antenna placement. We place the antenna in a symmetry manner. So what we really implemented, the system we implemented is 4 nodes of the FlexRadio, and all the antennas are placed here. 3 of them will be put into the vertex of a radio, of a triangle, and the fourth antenna will be placed in the middle of that triangle. And through this one, we can greatly reduce the cancellation requirement to support all the cancellations we need. Ideally, if we want to model all the channels, we need to have the cancellation blocks for all the channels. In that case, we need 12 of them. But here, since we use the symmetry of the placement, and the channels are similar and they are same, so we can combine them together and do the cancellation use only 1 models. And we show here, we only need 2 of them. We only need 2 cancellation modules. And we can deal with all the configurations, as we show here. The 5 configurations with 2 cancellation modules we are able to support. This is how we implement the system. We use it, we implement based on the National Instrument PXIe 1082. And it is connected to the XCVR 2550, and it can transmit on the 2.4 GHz channels. And it is then connected to our cancellation board, which is a PCB board showing in the right side of the picture. And on top of this board is our antenna placement, as shown in the bottom part of the left side of the figure. And let's see what's the performance of our system. Here's the thing we care the most is how is the full-duplex cancellation performance. As I said, we try to reuse of the modules, no matter in the digital part or in the RF part for our cancellation modules. So this is the performance we have. In the RF cancellation, we are able to achieve 68 dB of cancellation, and the rest of the noise can be pushed to the noise floor based on the digital cancellations. And totally together, for the details about how we do the preconditioning and how we achieve this, we reuse modules in our digital cancellation modules. Please refer to our paper. And here we show the performance of a 3TX and a 1X case. That's the most complicated case, since of the 3 of the signal will happen simultaneous in our system. We want to cancel it. So it's like this is the most complicated case. We show that we are able to support this configuration. And we show the throughput result of our performance. We implement the 4 nodes full-duplex radio, 4 node FlexRadio nodes. And we can show there, compared to the full-duplex alone and compared to the MIMO case, we can show a medium gain of 86% and 73%. And in the case of the diamond topology, we also tried in different places in our campus. And we show the medium gain of 47% and 38% of the improvement. This, I won't say that it's satisfies our expectation, just as we expected about this performance of the radio. So for the conclusion, I think the key takeaway of this work is that we treat this flexibility as resources, as RF resources you can use to tune, so that you can maximize the network performance based on the applications, based on what you need. Okay, that's all for my talk. I'm here to expect questions.
So for the configuration where you have a desired flow from left to right, why not make middle node a full duplex relay, which can in real time recast the signal and you'll get better than all of these schemes? Does that make sense?
Sorry, I didn't get your question.
So if I make the middle node a full duplex relay, which is taking 2 streams in and popping 2 streams out simultaneously in real time, so I can get in to out full through of 2 by bisection bandwidth of twice. And that would slightly do better than all of the schemes, would it? Or I'm not sure.
So you mean the desired float case, right?
Yeah, the desired float case.
Which one doesn't make sense?
So the middle node basically is a full duplex relay, which is taking in 2 streams and recasting them, amplify and forward or something like that in the real time and transmitting them back to the desired destination node. Wouldn't that do better than all of them?
Oh, that's the same thing. So think about the case. If you want to do I see what your question. You think that with a full duplex, we can use a TDMA, right? Is that the TDMA thing you want to
It's a real time. It's not even a time, and that's fine.
Or use the XOR channel.
Let's continue this offline.
Okay, thank you. Sorry.
Manu Bansal from Stanford. Could you talk a little bit about the use cases and the topologies you are imagining using the FlexRadio? And is it mostly infrastructure to client side, or you're thinking device to device communication? What's the best use case for this?
Oh, you mean the application?
Yes.
Yes. It's a good question. I think the one we are showing here is more like a paradigm of the FlexRadio. It's an idea. The most thing about it is the idea. We should choose this as a resource. We can do the resource allocation about RF resources. For the applications, as we can show that, like the flow demand, that's a very reasonable thing to assume, that in the network we cannot assume all the radios have the same number of RF chains, and the devices are diverse from each other. And I think even for assume that like the middle one is AP. And if you think about the one in the left side and the right side, they are the clients. I can also do this kind of operation.
Okay, it seems like there's another question, so I'll just follow up a little bit on that. So in that specific topology, like if you put that in the context of cellular networks where you can do simultaneous transmissions, in fact, that's what the base station does, you can start to do schemes like multi-user MIMO, where you will exploit all the antennas on your base station, even if the clients don't have the same number of antennas. So in that case, are you already getting all the possible performance by just doing MIMO, or is there something?
Yeah. If you want to see, you can try for the dynamic topology I have here. Is that even if you try to use a multi-user MIMO, 2 is the maximum you can have. And without full duplex, if you try your best, you have this interference alignment, all the physical layer technology you want to use here, this is the best you can have. The only thing that we see this improvement when you introduce a nodes, different nodes will configure as different operations based on their, like we show here. This is, I think this topology, when we find it, this is a very, very elegant, it's fundamental improvement for the network performance.
Thank you.
Thank you.
Okay, let's thank the speaker once again.